It's going to be giving a talk, why do our binary reverse shells over Wi-Fi, and take it away. Thank you. Right, thank you for that introduction. My name is Vivek, and I run a site called securitytube.net and Pentester Academy. So today I'm going to be talking about WIDOOR, which is wireless backdoors, right? Before I begin, you probably already noticed I have an accent. So in case there is anything you'd like me to repeat, feel free to tell me, right? Just a quick introduction about myself. Started as a programmer, used to work with Cisco's Layer 2 security team, 802.1 export security. Found a couple of wireless attacks, Cafe Latte, broke web cloaking, which is now owned by Motorola. And I have my own training company now, SecurityTube Pentester Academy. We keep doing a lot of stuff both online as well as in the real world. I'm the author of a couple of books. And we're going to release a new book at DEF CON as well. So this is the first self-published book called Make Your Own Hacker Gadget, which is how do you make your own Python from scratch, right, by using commodity routers and OpenWRT and all that. So I'm going to be asking some very simple questions. Whoever answers first can get a couple of these books. I have 10 of them, so hopefully it should be fun. Okay, so WIDOOR, what, why, and where, right? WIDOOR is actually a wireless backdoor for Windows. Now, the exact same principle can probably be ported to every operating system, right? Windows is more fun. Everybody likes to hack and break Windows, so that was my first choice. Why create this? Well, I had first spoken about hosted networks and the security implications of hosted networks probably 3 years back. Unfortunately, the exact status is prevailing today as well. So I decided to create an automated tool through which pen testers can demonstrate why hosted networks should be blocked. Tool is completely open source. You can actually go grab the source code from the GitHub URL. Okay, how many of you have ever used Airbase NG? A couple of you guys. Okay, Wi-Fi Pineapple kind of lowers the boundary. And how many of you have created fake access points, honeypots, and all of that? Some more, okay. Now, whenever you've probably done a fake AP, you've maybe used Backtrack Kali with an alpha card or a compatible card, Airbase. Some people may even have used host APD to do that, right? A kernel mode AP. It probably is more stable if you want to do better things. Now, interestingly, most people feel that access points or software APs on client cards is a Linux thing, right? Windows can't support that. But looks like Windows can support it, right? Anyone here heard about the hosted network? Couple of folks? Okay, great. Who wants to tell me what a hosted network is for the first book? Okay, there you go.
It's kind of about the way to create a virtual Wi-Fi adapter, so that way you can share access over one access point and another one. For instance, the best case is when you're on the airplane on go-go, you want all your devices to piggyback off one connection.
Okay, great. Here you go, first book. On Windows, interestingly from Windows 7 onwards, they have a very interesting feature called hosted network. Now what is that? If you've never heard of it, you're going to be shocked today, right? Quoting from MSDN directly, with this feature, a Windows computer can use a single physical wireless adapter to connect as a client to a hardware AP, which is typically we connecting to our enterprise access point. Now here's the interesting part after that, right? While at the same time acting as a software AP. So this is not mutually exclusive. While you are connected to a regular network, you can actually create a software AP on the same wireless card. Now if you're wondering, how can a card probably be on two channels at the same time? Well, the hosted network is on the same channel as the access point you're connected to. Okay? And if you aren't connected to any AP, the hosted network will automatically select a channel for you. Now, why is this feature available? To support personal area networks, right? You're at one of those hotels who wants you to pay per device. You can just connect your laptop, enable hosted network, and share that same connection with all your other devices. Now, if you wanted to test if your Windows machine supports the hosted network, it's actually a very simple command. You can just type in netsh wlan show drivers. And there is this little thing in here which says hosted network supported, right? Let's say yes. Do all built-in cards support hosted network? Yes. External cards? Yes. Anything which says it is Windows 7 Plus compatible has to mandatorily support the hosted network for Windows, right? The driver has to. There is no choice here. Unlike the Linux case where you had to search for cards, this includes all cards, right? If you have a Windows machine, you can try it right now. If it says yes, probably have something to worry about. So let me show you how to create a hosted network, right? We'll first use the command line, and then we'll talk about why dur and maybe why that is interesting. So you can create a hosted network through the command line, something which you can backdoor your friend's computer with the next time he forgets to lock it. The syntax is unbelievably simple. netsh wlan, unbelievably simple, but I forgot. Set hosted network mode equals allow, followed by the SSID of the network. So let's call it wicked network and key. Here is the interesting difference between using Airbase host APD versus the hosted network, right? In the former, you could create an OpenAP, WEP, WPA, WPA2. In the case of the hosted network, you are only allowed to create a WPA2 PSK network, right? That is the only option. You cannot do an OpenAP. So probably put in a key ABCD 12345. We can go ahead, run the command. The hosted network hasn't started yet. You can start it using netsh wlan start hosted network. Now before we do that, let's actually go to my Kali VM and start scanning the air. So what I've done is, just so that we can do the demo, I already have the MAC address of my Wi-Fi card put in, right? Just so that we can save some time rather than having to scan. At this point, of course, you're going to see nothing in there. Now let's go here, start the hosted network. Let's go back. Takes a couple of seconds. And there you go. Right? Did you see any pop-up, anything like that come up? Now, here is the even more worrisome part. When a client connects, you still don't get to see who connected to you. Now, it actually gets even more worrisome. If I actually go here, I could have been connected to a network, but do you notice the wicked network listed anywhere here? So you cannot see the hosted network you've created. So this is going to be an invisible phantom network once created, which will trail you for life till you use the same computer. Everyone else will see it, you won't. For a good reason, right? Now, if you're wondering, this is something which should be easy to detect and figure out. It isn't. If I were to even click on view network or view connection settings, do you notice you still don't see it anywhere? Right? The only place where it actually tells you that a hosted network was connected or created rather, unbelievably, is when you actually go and look at the list of adapters. Now, do you see a new adapter here which says LAN area connection 6 wicket network? Can everyone see that? This is the only indication right now, right? You can try connecting to it if you like. You already know the key, the passphrase. What you'd find is there is no pop-up. I can probably try doing that with my iPad. And you'll actually see there will be no pop-ups. So you should be able to see a wicket network. Is everyone seeing it on their mobile phone or? Okay, perfect, right? Try joining it here. I've joined my wicket network, right? Do you see any pop-up on my Windows computer which tells me someone connected to you? Okay. Create a fake AP on Kali with Airbase or host APD. Does everyone hate it when you have to go through the pain of setting up your own DHCP server? You get one free with the hosted network. Right? It's already set up. Of course, logical enough because it's a personal area network, right? You would want to hand out IP addresses. But interestingly, you already have that now. Previously, you could basically just hop on pretty much any of the other adapters, right? And that's where WIDOR comes in, where you can go ahead, connect to the system, do a lot of fun stuff. Is anyone surprised and shocked here that you can do that? You know, do all of this? How many of you want to do this in your co-worker's machine as soon as you go back? Right? And this was really my litmus test. Unbelievably, I hoped for a couple of months, but ended up being a couple of years that I could just do this and nobody even knew. Right? So, what is the good and bad news? And by the way, I could actually have been connected to a regular wireless network, right? So I could actually be connected to the speaker network and the hosted network will still run. It might just change channel because now the channel is the one which the speaker network uses. So kind of change that to 1. And there you go, right? As soon as I connect to a network, the hosted network switches to that channel. But do you notice I'm perfectly connected to the speaker network right now? Do you note that? This is what we were talking about in the definition of the feature, right? Which is it can do both simultaneously. While you're connected, it can accommodate further connections to your computer. And of course, that is the whole intent. Or else, how would your personal area network function, right? If unfortunately you've forgotten to turn off ICS, which is turned on by default, internet connection sharing, anyone connecting can actually hop onto the internet or whichever other connected network, which makes this a perfect backdoor, right? All your traffic is tunneled through the machine you're hopping through. Now, what is the good and bad news? Well, actually, it's all bad news if you are the one affected. And all good if you're the one hacking, right? So, no alerts. And I did it through the command line. I'll just do it programmatically with WIDOR in just a bit, right? No alerts at all. The host remains connected to the Wi-Fi, which means if a piece of malware, this is post-exploitation, a piece of malware creates the hosted network in the background, you would never ever know something's going on because you never lose connectivity. Right? You can connect to any regular Wi-Fi network and the hosted network will just keep running in the background. There are no alerts when a client connects. Now, this is something I hoped Microsoft would have done, right? Pop, right? A little pop-up which says new client connected. Yeah.
Can I tell something? There's actually a piece of software called virtual Wi-Fi router.
Yes. Yes.
And that does actually show you.
Yes. So basically, programmatically you can do it, but natively Windows doesn't, right? Yeah. This is post-exploitation. Yeah. Windows 10 can actually even do it for the current user, the ones I checked. So, Yeah. So this is post-exploitation. The assumption is you're there. What we are looking at is a different dimension for a backdoor, right? Typically, we are used to backdoors which connect back whenever you're on the wired network. Your malware connects to the command and control. This is over wireless. That is the difference. It is post-exploitation. The exploitation vector itself could have been something, right? The GUI network manager doesn't show it. We clicked on it. We couldn't find the hosted network anywhere. The only place is the adapter settings. Now, why is this worrisome? Assuming you've been infected by, a malware, or someone managed to go ahead and have command execution, they can actually create a complete software rogue AP. Enterprises, from a wireless security perspective, are always worried about rogue devices, right? Can I find these devices connected to my network, which are probably open Wi-Fi, or through which someone can connect back? Now, with hosted networks, every machine is actually a rogue AP. And keep in mind that a hardware rogue AP would have to be connected to the switch port, which means you could always go ahead and figure out which one of the ports are active, look at the MAC addresses and a bunch of things, and maybe even figure it out. Here, you're tunneling through one of the laptops or workstations with Wi-Fi access, right? The best part, you save money on hardware. It's always good. Now, interestingly, I kind of talked about the hosted network and all of this the first time around 2 or 3 years back. We even did contact Microsoft at that point, saying, well, could you at least have a pop-up? So Microsoft's final answer to me was, you're abusing a legitimate feature. Right? So, end of discussion. And they finally only wrote that when I said I was speaking at a conference. Right? And this was years back. Every new version of Windows, I'm hoping there would be something. Yes, third-party software could be used, but natively, Windows doesn't show you anything. Okay, so I do a lot of wireless teaching, and we show this to our students, and the first question they say is, hey, we'd like to demo this to our clients, right? Clients are okay if you say, well, you got infected and something can happen. A client isn't okay when you say, I'm going to type something in, right? Because that doesn't simulate the real world. So I created WhyDoor, which is what we are releasing today. But WhyDoor has a little twist. So I wanted the backdoor to be covert. And what I decided to do was, when the piece of malware runs, it automatically scans the air at regular intervals, right? And it waits for what I call a signal SSID, lack of a better word, right? So this signal SSID is what an attacker will bring up, right? You could even use the hotspot facility in your phone to do that. I mean, this is just any access point. Now, the moment WhyDoor actually sees that this signal SSID is available in the vicinity, it automatically starts the hosted network, right? And the hosted network would be started and keep running till the time the signal SSID is around. Once the attacker connects, probably goes ahead, tunnels his traffic, does something else, right? And then decides to bring down his signal SSID, WhyDoor automatically shuts down the wireless backdoor. So let me actually show you a demo of WhyDoor. I'm going to stop the hosted network, which I've already created. WhyDoor is written in C++. Simple reason is the Wi-Fi API only has the C version available right now. There isn't a C# version. You may have to probably write a wrapper around it. So in this POC, the signal SSID is OpenSysAim, and it'll continuously monitor the air. As soon as it sees this SSID, it's going to create a backdoor with this key, right? How does it work? We'll get into the working in just a bit. So I've pre-configured my TP-Link access point with the SSID OpenSystem, right? So I'm going to start WYDOR. WYDOR can run completely in the background. All you have to do basically on Windows is just call free console. So that actually frees the console. Just so that we can look at it interactively right now, I've commented out free console, okay? Or else it can just run in the background. So let's start WYDOR. It scanned. It could not find OpenSystem. Scanning every 5 seconds, right? So now I'm going to power up the router. Just hope this demo works. I've worked 100 times, but you never know, right? Final D-Day. Windows will automatically scan once every 1 minute. So it isn't going to be instantaneous. Probably take a couple of seconds for this to come up. And then the moment you actually see OpenSystem show up on the right, maybe in the next iteration, you should see the backdoor start. Windows is slow, as you probably already expected. So, as you can see, Windows still hasn't found it. I just booted up. Someone is already using a pineapple. That should probably be seen in just a couple of seconds. It does take a couple of seconds for Windows to refresh everything. There you go. See that? Don't I deserve a clap? Finally worked. Thank you. So it actually found OpenSystem, and the moment it found it, it started the wireless backdoor. We can verify that by going back. And there you go. Now you have your backdoor network which is running. Now, as you're probably noticing, we never lost connectivity, which is, of course, the feature itself, right? So for the end user, he can never figure out that something's going wrong. Now, what WYDOR does is once it starts the wireless backdoor, it goes back to scanning and keeps checking if, the OpenSystem is down or not. Now, this is a boilerplate code which can actually go ahead and be reused to start something like a meterpreter backdoor or a bind shell, right? I'll just explain the code. The code is actually quite straightforward. All I do is basically check if the network is available over here using isNetAvailable, which is actually a wrapper. Internally, isNetAvailable is going ahead and looking at every wireless interface which I have. There's a simple API called WLAN enum interfaces with which I get all the interfaces on the system. And for every interface, I actually check the list of network that interface sees. And once I go through that list, it's just a simple string compare to my signal SSID, right, to what SSIDs are available. Once I get my signal SSID, I start my hosted network. Again, simple API calls, nothing much to it. There are two API calls. One is called WLAN hosted network set property, and the other is hosted network set secondary key. The second one sets the key. The first one creates the config. Once the hosted network is created, all I do is just wait and check if that SSID goes down. If it goes down, I shut the hosted network. Now at this point, as soon as you found that you have OpenSysame or whatever is your signal SSID. Right here, you can insert and start any program, run anything you like on the system, right? Could be a meterpreter bind shell, could be a reverse TCP. I mean, a bind shell would be good, a reverse TCP as well, but probably you want a reverse TCP which can iterate through a list of IP addresses, because you might not know what you as an attacker would get as an IP address. Generally, it's the first one in the range, but just so that if there are any issues. Now, WYDOR, sorry. So now let me go ahead, disconnect the hardware AP. I mean, it has to be stealthy. There's no point starting it once and not being able to stop it. So we still see OpenSysame. Windows actually caches the results for quite some time. There you go. Shutdown signal received, right? It saw that OpenSysame isn't available, and if we go back basically over here, hold on. In the list of networks, you'd see that. Now, if I reconnect it back, actually see it come up once again. In just a couple of seconds. Windows caches results for quite some time. It's unbelievable, but when you actually get into Wi-Fi programming, it's quite painful, because a lot of times Windows even caches results across reboots. Do you notice a lot of times when you shut your Windows laptop and then you kind of bring it back again, it shows you like a hotel network which you connected to a couple of hours back. It still has it in the list. So it does a lot of automatic caching, which you have to be very careful when you do all your parsing about. Now, what are the other things which can be done? You could make the signal SSID a regular expression, right? Does not need to be hard-coded. You could probably even make it a function of the MAC address, right? So you can be clever, just like most malware are now, when deciding which domain names to use to connect back to their command and control. All the same principles apply. I mean, this is no different. Same goes for the key as well. What are the advantages? Well, in a regular attack, you'd probably have to use some common network in between to connect to your victim. In this case, you're using your own little private network, right, to connect to the victim. Why is this interesting? As I mentioned, the victim never notices anything unusual unless he actually checks his network settings. How many of you check your network settings every day, week, month, ever? Okay. The other interesting aspect, of course, is keep in mind that all your wired side defenses can never pick the back door up. In a typical back door, they try to be as stealthy as possible because you're worried the IDS or IPS may actually notice an outgoing connection, right, to an IP address or to a domain name which is unusual. In this case, you're connecting directly to your victim. You aren't using the wired side anywhere, or really your enterprise network. Anything you would like to tunnel through the machine goes through the victim. So now the question arises, how do you detect this? Anyone? Okay, so one is that you can go ahead and of course monitor the air and detect this. But if you wanted to build a security tool on Windows, is it even possible to do detection? Okay, what's that? Okay, does that? Okay, so here is a hint. Does anyone know the name of the subsystem whose events we'd like to monitor? Anyone? The Wi-Fi subsystem. Oh, come on, all of you lost the book, right? The Wi-Fi subsystem. That's all there was to it. So, so Windows goes ahead and creates tons of events. Unfortunately, most of which isn't exposed to you. So if we monitor the different subsystem events, then you can figure out a lot of what is happening under the hood. Is there any tool which allows you to do that right now? No. So at Vidur, what I decided was to create a tool which can do that as well. I'm also doing a main stage DEF CON talk on the tool, which actually has a lot more capabilities than just pick up the hosted network. And the tool is called Chellam. So this is the defense side. Just going to demo the tool. There you notice it once again started the hosted network. Okay, I'll probably just kill it right now. Hold on. We'll start Vidur and basically we'll see how detection works. All the source code is available so you can play with it. Chellam, at least in my humble view, is the world's first wireless firewall. So when I run it, it's going to start with a bang. I have to do the ninja. The ninja changes color. I have 4 different colors around it. Right? So every time you start it, it's going to change color. So what does Chellam really do? It kind of goes ahead and a lot of shortcomings, which I as a wireless researcher always felt was there on Windows-based systems. So the first thing Chellam does is it actually digs deep into the APIs, and rather than giving you just the SSIDs, it'll actually give you the SSIDs and the MAC addresses of every AP around. Interestingly, the APIs provide that. Some tools have it, but not from a security standpoint. So I'll just show. Is everyone able to see this? Do you want me to magnify it a bit or? Okay. So just to give you an example, Chellam is now scanning the air and trying to look at different things which are happening. So let me show you an interesting demo. So one of the things Chellam can do is actually picks up a lot of subsystem events. Chellam took us around 4 months to build. Okay. I'll just explain what these events are in just a bit. Now, one of the things Chellam does is it can actually do honeypot detection out of the box. A common question which I always get is, hey, someone created the Wi-Fi, started the Wi-Fi Pineapple or Airbase NG, right? And no client can pick it up. And the client doesn't know that this AP actually was created by an attack tool. So what if I made Windows smarter? Okay, so now let me go ahead and create a fake access point with Airbase NG. Oops. They've changed all the names. Yes, quite, yeah, pain to remember, but okay, hold on. Let's quickly check. It's WLAN 1? Ah, thanks. Okay, so now the attack tool has started. Chellam can actually monitor everything in the background. There you go. Do you notice that? It actually said it's found a fake AP. Right? And just so you know I'm not faking it, you can decide to give me a random name. I'll explain, of course, how it works. I mean, it isn't meant to be a black box. Yeah.
Use that Wi-Fi Pineapple access point?
I'll actually show you how to write signatures. Right now we have signatures for Airbase. But at the DEF CON talk, I'll actually talk about how you can write your own signatures. I don't own a Pineapple, so I couldn't write the signature, but you can write your own. So let's say we just put in something, I don't know, completely random, right? Just so you know, I'm not faking it. So right now the way it works is, before I start the other demo, is chellam will scan the air, and let's get into how it works just so that you know something interesting. It'll actually even point out the fake AP, right? Just so you know that this is the fake AP, the red one from TP-Link. Now, how does chellam do this? Now, this is beta software. If it crashes, don't blame me. So if I click on any of these APs, right? Am I sniffing the air? I'm not. Right? Will the next version of chellam have a low-level device driver? Yes, I'm already working on it. Okay, but right now, here is what chellam does. Chellam queries a lot of the wireless APIs and reconstructs the beacon frame of the SSIDs it sees. So I basically reconstruct all of that data so that I can look at a given beacon frame, what are the different information elements that beacon frame would actually have, as you can see here, right? So is that visible? Okay. So as an example, the AP which I clicked has SSID supported rates and a couple of other things, right? Now, what chellam does is, if I look at the fake AP, wireless hackers have, had fun for too long. In the sense, Wi-Fi attack tools never improvised. Wi-Fi attack tools create beacon frames, including the Pineapple and others, which use the minimalistic number of information elements required to be acceptable as a real access point to clients, right? They don't work hard. They don't try to clone a real access point. I mean, people don't even change MAC addresses. How many of you actually change MAC addresses in the same range as the vendor of whatever setup you're trying to, just one or two, right? So that alone is a dead giveaway. Okay, Airbase, NG, who started it here? Alexis, Spark Wi-Fi, anyone here? Someone is actually using that around. Yeah, chellam will pick all of them up. Airbase is fingerprinted at this point. And actually fingerprinting the rest is trivial as well. You'll just see why. So this is the Airbase beacon. This is the Airbase beacon, yeah. Most of these fields and their values, nobody ever changes. So by different versions, you can actually create a blacklist. The only way an attack tool would probably escape a blacklist is by ensuring that it has a clone option, right? So if I want to create a fake AP for the speaker Wi-Fi, it should take an input for that SSID, take a beacon frame, clone that exactly, right? That's the only way you could probably beat most blacklists. Now, so what's that? The second one? Someone has a script. So interestingly, here is the other thing which we've done. You can actually use this till the time it isn't too profane. That's you can also use this as a wireless scanner. Now, Windows, when I was researching on this over the last couple of months, Windows does something which I find quite stupid, which is it scans the air, gets the list of SSIDs, right? After a minute, it scans the air, and it might just go ahead and say, hey, okay, all I care about is what I received now. There are so many APs around which get left over from the previous scan, which are still around. So one of the things we did was, we basically said, okay, why not have a since start, since 5 minutes and up to 10 minutes. So you could actually walk around and pretty much fingerprint, or rather enumerate, all the access points in the vicinity through this interface, right? Including the kind of beacon frames it has and everything. You'd be quite shocked if you run this at an airport. You wouldn't find as many fake APs, at least Airbase based, as you thought you would. Like the moment we created this and I sat down and I put in the signature detection, I was like, okay, now let's go to the airport. I won't have to use Wireshark anymore, right, to go ahead and find the signatures. Let's see what is out there. There weren't too many, but you can try it on your own. The tool, this is freeware as well. What we did was we wanted both a blacklist and a whitelist based approach, right? Blacklists are great when you want to detect attack tools, but what if I could just whitelist stuff? So what if I could just go ahead, right click on my home access point and auto create a signature for it based on all the beacon frame IE elements, neighboring APs and all of that, and store it. So the next time you create your fake AP with the same SSID, I actually know it isn't the same, right? So that's what I added and made this basically a whitelist weight firewall. So you'd love this if you're a wireless guy. I could basically go ahead and right click on any one of these APs. Let's say, not that one. So let's say open SysAim. I could right click and say create rule. And what this does is it brings me to an interface where I can create a whitelist or a blacklist. Now, it basically already puts in the BSSID, the BSS type, the physical type, the beacon period, the center frequency in case you decide to run your home AP at a specific frequency. And it actually allows you to decide whether this can change or not. So if you have a AP set at auto channel scan, you can actually go here and say, okay, when I create my wireless firewall rule set, it's okay if the channel changes. That's fine, right? Or if you are wanting to rigidly fingerprint it, you can say, okay, the channel can never change as well, right? And then you can go down to the rates. The best part, or probably the most difficult to beat, is going to be the sum of the neighboring APs. So what I've done is, generally, APs don't change locations very often. So if you have a home AP, you'd probably find a couple of your neighbors around. So I'm enumerating your neighbors as well. And the rule set says at any point, at least a couple of them have to be around the next time I see open SysAim. Right? So an attacker at a coffee shop or at a hotspot cannot just spin up something, even if somehow stalked you and managed to figure out which AP you're using so that he can clone the beacon frame exactly, which he can't. He can never, right? Unless he has a copy of that. And then there are a bunch of other things as well. You could actually go ahead and create this as when the rule should be tested. Only when you connect to a network or when you're scanning networks as well. Right? So if you use Airbase NG with an option where it responds to every probe request and you enable scanning, this can automatically tell you there is an issue. Question? Yes. Yes. So for example, you can actually select an SSID which has multiple BSSIDs like a hotel network. And then you can create the rule set. So you could have a full drop-down list here. Is there anything here which has multiple? There isn't anything here which has multiple right now, but it would basically do that. The only problem though is if you mix and match different vendor equipment for the same SSID, right? So keep in mind that then you will not be able to get like a very rigid definition of a beacon frame. So what I kind of preferred was a combination of SSID and BSSID rather than the SSID alone defining what to search for, right? Now, Chellam can do a lot of this stuff. I have a DEF CON talk. You can come see the demo there. Now, what I'll demo is it can detect events as well. So, Chellam can go ahead and detect every single Wi-Fi event happening on your Windows machine, right? This includes roaming events where you disconnect and quickly roam to the next AP. This includes connecting to a LAN, connecting to a network, disconnecting, authenticating. Let me show you how this works in just a bit. I personally love Chellam so much that after this, it's very clear who I'm connecting to and where. There is no confusion ever. And a lot of times when you actually run fake access points and someone does a deauth and you reconnect, Windows might not even show you a temporary disconnection. Yeah.
So I was wondering, you mentioned you don't have rules for Pineapple. Are you looking at maybe like a cloud model or any contributor?
Exactly, exactly. So what I'm looking at is basically where the community can submit rules, and eventually you can write your own rules in Python, actually Jython, but yeah, so that anyone can go ahead and push stuff. I'll just quickly demo. I just have 10 minutes. I'll take the questions at the end. I'll just finish the demo, and I'll take all your questions. Just want to make sure this runs first. So as an example, let me actually shift the alerts to the left. So now when I, let's say, disconnect from a network, right, you'll see all of those little alerts show by, which actually tells you that you just disconnected from this network, right? I don't know if you can see that. And this tells you the MAC addresses. So let's say someone deauths you and you end up connecting to his fake AP. This will actually catch that event. And this will tell you that you just switched an access point. Okay? It won't interfere with the connection, but it'll just tell you that in just a bit. Now, I'll just do the last demo. I think I hardly have any time. The hosted network one. So it can even go down and pick up all the different hosted network events. So I've just enabled the alerts for the hosted network, and chellam can completely run in the background. And I could, I don't know, start Vidur. So as soon as the hosted network is created, chellam will jump up. One of the other ways to simulate is, of course, just to create a network right here. There you go. Right? Of course, one can argue that if you have a malware running on the same system, then it can kill chellam and all that. The exact same arguments of what a rootkit could do to an anti-rootkit solution is valid here as well, right? So I'm not going to debate that. But could you pick it up? Yes, you could. If you're already running at the kernel level, maybe you have a kernel module, which is what we are building into chellam now. At this point, chellam depends on the APIs to pick up all the information. So I'm actually building an intermediate driver so that we can look at every single packet which goes up and down. So that way we have our own data source rather than looking at Windows's APIs to figure all of that out, right? Once that happens, chellam can even actively prevent. So at this point, I could prevent, but all I can do is disconnect you, right? The subsystems send me all of the events after they've happened. I mean, it is an infinitesimally small time, but the event has happened. With the kernel mode driver, when I see a beacon frame, probably from an attack tool, which shouldn't be there, I actually won't pass it up. The exact same principle as any other network-based firewall would use, right? They don't pass up the frames to the stack. They actually drop it right there and log it. That would be the next version. I wish I could release that for DEF CON, but kernel mode drivers, to make them stably, does take a little bit more time, or else nobody will install them. Getting the right certificate and co-sign from Microsoft itself is a long process. Windows 10 onwards, you have to have everything signed by Microsoft, for especially kernel mode drivers, right? Is there anything else? Okay, do I have any time, Gurmeet? Okay, questions? Yes, questions.
Are you releasing that on that?
Yes, so I'm going to be doing actually 4 wireless talks at DEF CON. I'm doing 2 talks in the main stage. One is chellam, the other is how to create your own network IDS for forensics. So what it does is it takes PCAP files, pushes it into a SQLite database, and then allows you to just run plain SQLite on Wi-Fi packets to do forensics and attack detection. That talk is on Saturday. Chellam is on Friday. And the wireless village, I'm going to talk about WPA Enterprise and how to automate attacking WPA Enterprise live by controlling WPA supplicant using the WPA control API and the dbus API, which is available. A lot of people don't use that, but you can actually automate WPA supplicant so that it can try and maybe connect to an enterprise networks and dictionary attack passphrase combinations for what it's worth, right? So that's in the village, right? Any other questions? Yeah, all of this would be released, yeah. Yes. So you can actually go ahead and have a policy which does that. What I've found during most audits is 95% people don't even know it exists. Of course, keep in mind that because this is post-exploitation, a piece of malware, once it privilege escalates, yeah, and runs in kernel mode, after that, none of the policies matter. So, yeah, question?
That was my question.
Okay. Yeah, there is a group policy you can apply. Okay. Okay, thank you. Thank you very much. Thanks.